Algebra 1, section 7.2, we're dealing with a method called substitution. Now, you dealt with graphing last section on how to graph and once they overlap. But there's a way that you can do it without graphing. In fact, you'll learn a method here. You'll learn a method for substitution, and 7.3 you'll learn another method called elimination. Now, substitution, basically, what we're going to do is because x and y are the same, they're interchangeable for each other. So whatever x is here, it'll be here for this x, and y here will also be y for this x. So what we're going to do is we're going to replace, because you can solve an equation if it has a maximum of one variable. But because each of these has two missing variables, I can't solve them alone. So that's why I need both of them. So let me show you. You're going to choose an equation to solve for a variable, preferably with coefficient 1. What that means is I'm going to choose an equation that has a variable with a 1 in front of the coefficient. So in this case, this has a 1 also. And what I mean coefficient 1, when there's no number in front of the variable and it's already by itself, that's perfect. And I'll tell you why. For example, if I took here 3x plus y equals 5. Now, I'm going to solve for my variable. So basically, I'm going to isolate one of my variables. I'm going to isolate the variable with 1 in front of it. That's y. So when I isolate, I want it by itself. What is it attached to right now? 3x. So I want to take that 3x and I want to go ahead and bring it to the other side. So I'm going to subtract 3x from both sides. I end up with y. It doesn't matter if 3x is first or not, but I get y 5 minus 3x. I'm not trying to get into y equals mx plus b form, so I don't have to worry about putting the x in front. All I have to worry is get this by itself. Here's the reason why substitution will only work with variables with 1 in front of it. If you have no variables that's already by itself with just the 1 in front of it, then you're going to use the next method, which is section 7.3. But when you see one by itself, it's easier to use substitution, and I'll show you why. Because if this had a 2 in front of it, okay, that means in order for me to separate it, I have to do what? I have to divide it. So then when I divide it, I get a whole bunch of decimals or fractions and everything like that, and then it makes this whole situation even more complicated. But if I don't have to divide, if I just have to move everything to the other side, because y or whatever variable, it can be this x, this y, this x, this y, it doesn't matter, just choose one that's all by itself, and then bring it to the other side. So I have y equals 5 minus 3x, okay? Once I have that, that means y equals 5 minus 3x for this equation and this equation. So here's what I'm going to do. I'm going to take y equals and I'm going to put it in a giant bubble. Remember those parentheses? So I'm going to put it in parentheses, and then I'm going to go ahead and put it in the other equation. So this is the equation I solved, yes? So I'm going to go ahead and put it into the equation for y. Why y? Well, this equals y, so that means this y and this y are interchangeable. I'm going to keep everything else the same, okay? So that means I'm going to rewrite this equation, but instead I'm going to erase this, still equal 10, and I'm going to put parentheses 5 minus 3x in front of it. So everything's the same, except I've replaced y for 5 minus 3x. And I can do that because they're interchangeable. Y equals this entire equation. Why did I do this and make this problem even longer? Well, if you look, now the whole equation is in terms of x. Once I do that, then I can just solve like any other problem, because now I only have a maximum of how many variables? Just 1. So that was the whole goal of substitution, so that I can solve one problem for a variable, replace it, and then I have it here, okay? So what I'm going to do here is I'm going to go ahead and take this, because it's negative, this is a negative 1, and I'm going to distribute it. So I'm going to bring down 2x, okay? I'm going to have negative 1 times 5, which gives me negative 5, and then negative 1 times negative 3x, which is positive 3x equals 10, okay? Then I'm going to combine. So that is right now I'm just solving. Once I figure it out, then I'm going to solve, okay? So I'm going to do 2x minus 5. So I'm going to combine like terms. So 2x plus 3x is 5x minus 5 equals 10. Then I'm going to add 5 to both sides. I end up with 5x equals 15. Divide both sides by 5. I end up with x equals 3. That's one answer. Yes? And then I have to do it for the other. Now I have an x. Once I have an x, easy. I'm going to plug it in. Which one can I plug it in? It doesn't matter. This x is for this and this equation because we're solving for both. So I can plug it in. Let's plug it into this one. So 3 times x, which is 3, plus y equals 5. Now that I have x, I have how many variables left? Just one, this y. So now I can solve. 3 times 3 is 9, plus y equals 5. I'm going to subtract 9 from both sides. I end up with y equals negative 4. So my answer here is 3 comma negative 4. Okay, x comma y. Okay, this means that if I were to graph these two equations like I did in the last section, they would overlap to 3 comma negative 4. And again, this term substitution will only work if the coefficient is 1. And when you have no coefficients that's 1, it doesn't mean you can't do substitution, it just makes it more difficult. Okay? So when this happens, then you might want to use our next section, which is 7.3. So let's try one more problem. Go ahead and write this board down. Okay? We're going to try one more problem. Okay? For this one, lucky enough, this equation, the x is already by itself. So when that happens, all I have to do is bubble it. So no, this is even shorter because no problem we have to work out or isolate because x is already isolated on one side, everything else on the other side. So I'm going to take it and I'm going to replace it for this x. So now, instead of this, I'm going to have 2 times 2y plus 6y equals 15. Now I'm going to multiply. 2 times 2 is 4y plus 6y equals 15. I have 10y equals 15. I'm going to divide by 10. I end up with y equals, I'm going to divide top and bottom by 5, so 3 over 2. This is my y. And again, I'm not yet done. I have to do it to the other side. So now I'm going to plug in for other variables. So I'm going to take this, okay, and plug it in. Which one do I plug it in? It doesn't matter. I can plug it into the original equation. I can plug it into the second equation that I plugged in again, because y should be the answer for both. But because this looks easier, I'm going to go ahead and plug it into that. So y equals 2 times 3 over 2. Try not to keep it, try not to put it in decimal, just keep it in fraction. When I have a whole number, I'm going to multiply the whole number by the top. So x equals 2 times 3, which is 6 over 2. And then if it's not a decimal and gives me a whole number, I divide it. 6 divided by 2 is 3. Right? So my answer means that if I were to graph this, I would have x comma y, which is 3 comma 3 over 2. Okay, so go ahead and try page 399, numbers 8 and 9, page 399, number 8 and 9, and I will see you in class.